All right, we're going to try this. I don't know if it's going to work. I have no idea if any of this will work. If you're watching this and there's something like you don't hear sound, I guess you won't hear me comment, so it doesn't really make a difference. So this video is going to be a little bit different than my other videos. I wanted to explain a little bit about how I do VR flight sim stuff. In particular, something that I spent the last week and a little bit working on is this box up here that I designed, 3D printed, figured and built that now works pretty well. So this is my VR cockpit that I usually kind of fly with all the time. When you see my other streaming videos of me flying, I was hoping to have my Htc Vive little webcam on the front working, so I could just video that. But it suddenly decided not to work. There was a software update and they took away that functionality. Stats. Anyway, so I've got a crappy little webcam I bought at Valley Village, streaming through. Picture quality is terrible, the lighting sucks, but it shows what I'm doing. So I'm going to actually be doing this live. I'm going to do live switching with OBS, switching between different windows to show. I want to show you the whole design process of coming up with this idea, making this thing, and getting it to work. Once I do that, I'll go into VR and explain, and I'll show you why I need it, why I wanted this, and show you how it works now that I have it. Quick run through of this part is this is my flight yoke. It just shows up in Windows as a joystick. Most of these things just show up in joysticks with axes and buttons assigned to whatever functions explain. So it's my yoke. These are the throttles. I can assign them to throttle mixture, or in this case, for flying a Diamond TS2, it's 200 throttles, the engine fuel levers, and an oxygen lever to turn the oxygen system on and off. Underneath here, I have a Saitek switch panel, which gives me a lot of the functions. One of the things with flying VR is you have to use this VR hand controller to reach out and control levers and knobs, which if you're sitting here, becomes a problem. It's in the way. And it takes a little bit out of the immersion factor. Because you feel like you're in an airplane cockpit and you want to reach out and touch things, but you have to reach for this thing first, then line it up, make sure it links up, and pull the trigger perfectly, push it just right. If you move like this, you could end up hitting the wrong button. Sometimes it's a space of a millimeter. So these things are really nice because they give you tactile control. Initially, I wasn't sure how I would like it because, like for example, this is the flap switch. In most airplanes, the flap switch would be down here. You have to reach up here. I find when I'm flying in VR, the disconnect isn't that bad. I know my cockpit that I built. I know where the switches are that I need, and my brain just sort of like makes the connection. I'm looking at the switch in VR, seeing the button, and it doesn't trouble me all that much. So yeah, I will take you in and show you my design files, sort of the process that led me to creating this little box. Really, it all centers around this knob, a dual concentric encoder. In a lot of the planes that I fly in VR, there's a Garmin G1000 system, which is like the big screen GPS that you see in the cockpit. And in order to program it, you have these two knobs, outer knob, inner knob, and a push button. To enter an airport or a waypoint, you have to enter a 4-letter code to access it, to get it, to add it to your navigation. To do that in VR, you have to reach out and line this up with outer knob or inner knob, just right, pull the trigger, twist. If you're lined up and you pull the trigger, but then you move backwards, you're now moving this knob, which erases what you were entering. So it takes the simple job of entering a 4-digit code from a 10-second job into like a 2 or 3 minute job, which I found super frustrating last time. My head while I was flying, I started to design. So I'm going to move over here and I'm going to switch what you can see to some web browser works to give you an idea of how I came to this and how I did it. So let's see. So I've just got a web browser open here. It's got, right now it's the Logitech page. So I wanted to show you some of the different hardware that's available for flight sim, cockpit making, stuff like that. So I have a bunch of this stuff. Like this is my yoke. This is one of the throttles I have. I have 2 of these modules. That way I can have dual engine setups with dual mixture, dual propeller, or if it's just a simple plane, I can use the axes for something else like flaps or car key or whatever. And then rudder pedals, which you couldn't see on the video I had just a second ago, but they are down there and they're set up. I'm not a big fan of these rudder pedals. I haven't really flown real planes that much, so I don't really know what they're supposed to feel like. But they feel super sensitive whenever I'm flying something. I find it really hard to steer. If you watch any of my streaming flights, you probably notice that I'm all over the runway or taxiway going back and forth. It's probably the thing I like the least in the setup is this. And then this is the switch panel. So like you can see that the prices on these, they're not cheap pieces of hardware, but these are the cheapest of the pieces of hardware. The flight panel is the part that's on right above my yoke. The nice thing about these usually is that they've got a screen so you can see what they're doing. But the problem is I fly in VR. I can't see the screen. I don't need the screen. So it doesn't really help me all that much. So when you're getting into the more complicated things that I wanted to simulate, like the Garmin G1000, this doesn't get you there. It doesn't let you do it. There is a company that makes them called Real Sim Gear. Their hardware is absolutely gorgeous. It looks exactly like the G1000. It's got all the controls. All this stuff is mapped. It's got 2 displays in it that you can pull from X-Plane and put. They're like just basically monitors. But like you can have this on your desk and literally be sitting in front of a G1000. Which if you're actually going for your pilot's license, your VFR rating or something like that, these are really handy because they get you familiar with how the system operates and like makes it just muscle memory. But for me, I don't need this. I'm flying in VR. I don't need the screens. A lot of these buttons are duplicated on my Saitek controllers. I don't really need them, but spoiler alert, I think at some point I'm going to design an entire panel like this just without the screen and make buttons and make more knobs and have it do the stuff I want to do in VR, but feel like this. The other issue with this is the price. This setup is $2,000 US dollars, I believe. They have other setups. This one is $3,000. This one is $5,000. It comes with the yoke and the throttles that I have. I don't have that kind of money to buy those things, and I don't have a need for them at that price point. So this wasn't an option for me. So I started shopping around, knowing that I could do a little bit of basic electronic work and try to maybe make something myself, just a simple panel that could map the knobs out and control the functions within X-Plane. This was the stumbling block. So the knob on the Garmin G1000 that was giving me the most trouble. Show me details. Is this dual concentric knob in the bottom? This is the knob with the inner and outer ring. That's really, really hard to control within VR. Really annoying, really frustrating, makes doing simple things impossible. So this is the single dual concentric knob. So it has two knobs on top of each other and a push button. Easy enough to figure out. It's $30 for the one component, one of these. I felt like that should be cheaper. Electronics components, especially, like, I'm not putting this in an actual airplane. If I was making like things to go in an airplane, sure, make them more expensive because they have to go through a lot more rigorous testing to not catch on fire and blah blah blah. But I wanted to figure out a cheaper way, because this is $30 for one of these controls. If you look on Amazon, there are dozens of packages like this, which are just a single rotary encoder, it's not concentric, and a push button. 12 of them, or 5 of them, for $14. That's way cheaper. It's way more cost effective to go this route and make things work. So I did a bit more searching, and I found this guy, Shahada Abubakar. I hope I pronounced that right. I probably didn't. I apologize for that. Who 3D printed and made essentially two cheap rotary encoders into one also cheap dual concentric encoder, just printing out two little gears and a little bracket to hold both things. It's a brilliant design. I've seen a few of similar designs online since, but this is the first one I saw, and this is the only one I saw until I finished. The other thing I really liked about this is that he shares his Tinkercad design. Tinkercad is the main program I use to do all my 3D designing in. I think it's really designed for kids, but it's super powerful, and it's web-based, cloud-based, so everything you design is online. I can go to it from any computer. It really lets you do a lot, and I haven't run into a lot of roadblocks, just simple things like making angles that to try and like design for real-world objects has been my only stumbling block. But because he designed this in Tinkercad and shared his Tinkercad design, it allowed me to modify it for a mistake I made in ordering the encoders for it. If you notice, his encoders are the flattened knob style that you would find on a, I keep thinking it looks like a stove knob that you would take the knob off, and that's the way that works. Maybe an amplifier, but actually my guitar amplifiers all have this kind of control. So with the knurled knob with the spines in it, which wasn't too bad because his Tinkercad design allowed me to go in, take the hole out, and fix it. I'm going to show you in a second how I did that. The next step of it was figuring out how to control it, how to electronically plug it into my computer, and therefore be able to assign it all within X-Plane. And that's where this little guy comes in. This is an Arduino Pro Micro. It's not by Arduino, it's by another company, but it's Arduino is open source, so other companies make the same hardware, just cheaper. This little board allows me to flash the firmware on it with a program called MMJoy, which is an open source program that some guy created, and it lets you plug in all different kinds of buttons and accesses, and then wire them up and make custom Windows joysticks. There was a bit of a learning curve for this part. I spent a lot of time looking at a piece of paper with a diagram with my brain hurting. I eventually got it figured out and was able to go in and basically create profile. So this is pulled down just now from the controller I made, and shows how I wired everything and configured each button and set timers so that it all works. That's all saved on the little Pro Micro. So I can unplug power from that and plug it back in, and it remembers it. It's just it programs the chip itself, and it worked really, really well. I was really, really impressed. So that covers the electrical portion of thinking about it. I'm going to show you some pictures of actually me doing it. I'm going to go into Tinkercad now and show you some of my design process. So it all started with trying to get this model so that I could get the measurements for the holes on top of it, which were important for me to have be the right size and the right angle for this shift on top, so it would fit well on top. This was probably the thing that took the longest of the whole, other than soldering all the wires, and was the most frustrating because I got this. This is the only file I could find, and it was really difficult to get the 3D file into a program I could use to edit it. I had to put it through like 4 different programs, and eventually got it in. But that's probably just due to my inexperience in 3D design and trying to MacGyver solutions to problems. So this is the first design file for the rotary encoder. I did modifications to it. So Tinkercad works as a subtractive and additive editing concept. So you create 2 shapes and you combine them. So shapes can either be solid or holes. So this is an example of a hole. If I move it over to shape, and cover part of the shape with it, I have no idea if I am. Then I can combine them, and it cuts that shape that is the hole out of the shape that's the solid. It's a pretty simple concept as far as how it works. When you first start doing this stuff, you sort of look at it and go like, how am I going to make the shapes I want by doing that? But like, because he shared his Tinkercad file, I can actually go in and you can see where he put holes to drill holes for screws, to put the hole for the shaft for the encoder itself. Really good design. But I ended up not being able to use it because I ordered the wrong encoders. So the first problem with the wrong encoders was, rather than having this kind of shape for the encoder shaft, it had this kind of shape. So I was able to find that shape with the spines on it, and instead of cutting this out of it, I was able to cut this out of it. So you can see that I've put that there. The other problem it created is the length of the encoders I ordered were different. I'm going to take you into a little slideshow now. Actually, no, I'm not going to do that yet. It's such a great idea to do this live. I'm going to go back out to here, and I'm going to show you the second design I did. And then I'm going to go in and explain to you why I made a second design. So the second design, so if you remember, his design was open and used bolts and nuts to set the spacing for the encoders. Now, in theory, I could have done that with mine, even though the shafts for my encoders were longer, but I didn't have long enough screws to do it. So instead, what I did is I essentially designed it as a box, and I set the height within the design. So if I move this box out of the way, you can see that the gears I have are still there. I modeled my encoders. So I took measurements of my encoders with calipers and created a 3D representation of them so I could get the heights right and make sure everything was aligned. I extended his gears to fit the shaft of the encoders, and I extended the shafts for these to compensate. So when it's done, it makes like a nice closed-in enclosure. It makes an enclosure for the gears and everything to sit inside. I didn't. This isn't perfect. I got it printed out and set up to a point where it's usable and it works, but it's not perfect. There's some. I think something is off by a millimeter or two in here, and I'm probably not going to print it out again because I've got it working. I've worked around the problem. If I break it or if I need to make a new one, I'll shore up the design. In fact, that's what these guys are. These are shims I printed to try and compensate for the incorrect measurements here by filling space rather than printing the whole thing out again. Just sort of jury rigging something. Because it's just for me, it doesn't matter. The other thing I learned, a very valuable lesson, when you're messing around and moving parts around that have threads, don't just mirror it to rotate it, because what's going to happen is your threads are going to go the wrong way. So on the 3D printed part I have, it's normally left for loosening and right for tightening. That's how everything in the world is for tightening screws, except for this part. You have to turn it left to tighten it and right to loosen it. So I had to make a special nut with reverse threads to compensate for that, so I didn't have to print a whole new box. I fixed it in this design, but that was one of my silly problems I made. So I'm going to open up some pictures here to show the process. So this is my prototype of his design, an initial printout. So I 3D printed these parts. I didn't have the length of bolts I needed, so I just used some utility wire to try and get them the right length. So this is the dual knob, this is the shaft, this is the collar that goes in, 2 gears are here. This is before I lengthened them, but I just wanted to try assembling it to see if the gearing would work. And here's some more parts. So these are some other switches that I ended up installing. These are the 3 encoders that I got with the package of 5 that I ordered. Getting ready to go in. This is my Snow Lab mug. It's my favorite mug from the Sudbury Neutrino Observatory in Sudbury. So this was my Mark I of my panel, the first prototype. It's just a flat panel, open in the back. I hadn't wired anything. This was an attempt that I 3D printed at compensating for not having long enough bolts. It worked initially, but I ended up not liking it, and then I went with the solid box design. This is what it looked like on my flight panel. It was all right. It would have worked. I found that the knobs were too close together. I probably could have gotten this all done and then it'd been fine because I'm in VR. I can't see that it's open in the back. It doesn't matter. I can't see the flaws in the print. It doesn't matter. But I got to a point where I was just like, that's too tight. I want them spread out more, and I might as well do it right. And I want more room to wire it. This is the printout of the boxed encoder. So the last design I just showed you, this is it all assembled. It worked out really well. I can compensate for what I mismeasured by tightening and loosening these screws in the back, and that pulls the encoders out and allows me to center things. And that's it disassembled. So you can see here the gears are wider. This is a bit longer to compensate for the fact that the encoder shaft itself is longer. Yeah, it worked pretty well. This is me starting to wire it, so I ended up deciding to go with a bigger panel. I'm going to get to my browser here. Where is Mark 2? Here's Mark 2. So I ended up making a bigger panel. Actually, I can take you back to Mark 1 and show you what that was. So the small panel we had that I just shown you is right here. So this is where I came up with a lot of my layout and figuring out how to get the angle right. So this angle down here is mirroring the angle on my Saitek panel that I wanted to sit on top of and nest into. These holes here are the same size as the holes in the mount, so I wanted those to be right. And then this here is basically my layout for where I was going to put the encoders. So I would just select all these and turn them into holes, and I essentially make a drill bit set, and then just push it through that panel and create the holes. I ended up printing this, and it was all right, but I wanted to have it enclosed. I wanted to have the wires inside and have it be a bit more clean. So I ended up going back to the drawing board and redesigning the Mark II. Which is this. So it's a wider panel. This is the panel itself. The box is enclosed with a little hole in the back for running the cord out. And then all the switches and knobs would get attached to this panel. The wiring would be done on the panel, so I'd have lots of room to work and solder. And then all the wiring gets sort of shoved into the box, and then it gets bolted to the front. The cord gets fed through, and should be good to go. The nice thing about this is I could take this plate off, plug it in, do prototyping, test wiring, test my configuration, make sure it's working, and then assemble it in place. Also, this gives me the ability to screw these into the hole on the Saitek panel, then affix this. So I don't have to do all that around the wiring. So going back to the main display, I'll show you a quick time lapse of 3D printing a box. So this was 7 hours, just taking a picture as it finished layers. For my 3D printing, I use a program called Octoprint, which runs off a Raspberry Pi. It allows me to control my printer, and it allows me to put a little add-on called Octolapse that lets you do really cool time lapses of prints. So that's the box being printed. This is a time lapse of printing the rotary encoder parts. It's got a function where you can animate the print head, so it takes a picture and then it moves the print head and takes a picture. I sometimes do it because it looks kind of fun, but I don't usually like it because I like to see the print come together. But that's those parts being printed. So once I got it printed out, so here's the encoder printed. Here's the beginning of the wiring. So I broke off some blank circuit board material to attach to the back of the encoders, just to give it a more solid foundation. I didn't want the wires bending the contacts on the encoders and breaking them, so this gave me a little bit more rigidity in that regard. This is about 20-30% through the wiring process. I forgot to take a picture further on when it was done, because there's a lot more wires. This is the front. This is a quick video of me actually soldering stuff. I just set a camera up. I was going to do a time lapse, but the time lapse app for my camera gimbal that day decided it wasn't going to work. So this is just me soldering and having fun. This is the panel hooked up, ready to ready to configure. You can see the Arduino micro up here connected, and things starting to work. That's configuring using the mmJoy program. That's the box all finished and put back together, and then starting to mount it. So those are the screws on top of the Saitek autopilot panel, and I'm getting ready to put in and this is the panel I'll put together. That's the dual rotary encoder in place, and yeah, I'm pretty happy with how it turned out. This is the whole cockpit put together. Normally on the other side I have a steering wheel and a gear shift. Steering wheel broke right before the shutdown, so I can't use it, and I can't afford a new one. So that's a problem that'll be solved at another time. So yeah, here's my rudder pedals. I got the 2 throttle quadrants here. I have a little USB keypad I bought at Value Village that I can map some buttons to, but I think it was at Value Village for a reason. It routinely just disconnects and doesn't work, but small problems. Here's my switch panel. This gives me this switch acts as the ignition key for older planes or planes that would have like a dual magneto setup, battery, alternator, different fuel pumps and pitot heat, lights, cowl, landing gear. This gives a pitch trim wheel, which is probably one of the most important parts on this panel. And these are the autopilot controls. I never use the screen. I don't even think it works in X-Plane because I'm using a third-party add-on to get this panel to work. But it works really well for me. Yeah, that's the time-lapse breaking. So what else do we have to look at here before we go into VR? X-Plane is up and running. I'm sitting in a DA62. Yeah, I think we might be ready to go into VR. So let's try that and see if it works. Well, it let us in. All right, I'm going to move over to the cockpit and put my VR helmet on. This is my Htc Vive. It's got a lot of wear on it. The foam's falling apart. The nose guard broke in half. But it still works for what it needs to, except for the webcam on the front, which doesn't work anymore. All right, so and I think, if I'm not mistaken, that my VR controller or my yoke isn't working. So I'm having trouble now because the performance is crap right now. Sometimes I get a frame rate issue that like I'm getting like 5 frames a second. I don't know what you guys are seeing, but that's not going to work in VR. So I'm going to quit this. I'm actually going to quit VR altogether. I had to know nothing. This wasn't going to go smooth completely. Okay, so that's quit. restarting up HTC Vive. So that happens often. I'm using, for my video card, I'm just using GTX 970, I think. It's 3 years ago when the HTC Vive came out, it was the smallest video card you could get that would power VR. But the lowest powered piece of hardware that you could use for it. And I bought that. It seems to be working okay. There's no sound? There is sound though, it's quiet? Okay, apparently the sound is quiet. I didn't know that. I've been talking for... Okay. I don't know how to fix it because I had the volume all the way up. Sorry about the sound. All right, let's try VR again. Probably because the microphone's on this. The microphone is on this part, facing another way. All right, starting up X-Plane again. So yeah, because of the video card, I often run into issues with performance, and I have to do a lot of tweaking to get the balance of detail versus what I want from it performing. So right now, okay, so we're in VR. That's working again. Let's make a new flight. So I'm going to fly my Aerobasque Diamond DA62. I'm going to go to St. Thomas Airport, just set up on the ramp. Weather's clear, time is that time, and now it's going to load. I have a lot of scenery, so it takes a long time to load. It does seem to be working. Honestly, though, despite all the headaches I run into with VR, it really changed how I do gaming. I rarely go back to. I don't like sitting at my computer to play games on my monitor. It just doesn't work for me. I find it boring. I'll sit on the couch and play games using a Steam controller. That works great, but couch is way more comfortable than sitting at a computer by myself. Other than doing stuff like this with Flight Sim, when my wheel's working, I do a lot of driving sim. So Dirt Rally is my favorite. American Truck Simulator, oddly enough. It's a very zen experience for me. I don't know why. It's all the best parts of driving. The weather isn't crappy, and the other drivers follow the rules. I find you can actually tune your radio in your truck to real radio stations. So I'll just drive around listening to the BBC or CBC, and it's fun. All right, so we're back in, and that is working a lot better. Although my controller has now disappeared. I have no VR controller, so one problem solves, another begins. Is this going to work? Can I have another one? So it's not drawing my controller for me. That's great. Oh, there we go. It's back. Okay, so this is the inside of the DA62. You can see we've got the two screens, the Garmin G1000. Everything's powered off right now because we're sitting on the runway. Something has happened to my setting file. I can't get rid of this stuff. So let's get this plane powered up. So these are all custom mapped. I can map these to anything. Like if you look on the inset, I can control each throttle independently. These are the fuel controls. This controls my oxygen slider. So if when I get above 10,000 feet, I can turn on oxygen and not fake pass out. All right, so I'm going to start up each engine. Just want to make sure I'm not blasting everything out with sound. So sound should be, interestingly enough, I'm not getting any sound. Oh, it's because it's in the VR headset. That's fine. Suffice it to say that there is sound, but that's not the important part of what we're talking about. So turn on the Garmin. And I'll show you what I meant by controlling it being a giant pain in the ass. So you've got your controller. You can reach out, you can drag things up and down. You can flick switches. And it normally works really well. You can, to use these, however, you have to get it lined up just so. So this, for example, this encoder has 5 different functions. You can rotate it, you can move it up, down, left, and right like a joystick, and you can press it. So if I want to rotate it, I have to line it up like that and then twist my hand. This one doesn't work too bad. Its boundary is pretty good. And if I want to go up, I have to make it so it glows there. And that does the trick. Using this, however, you can see how little tiny movement. So that's the outer knob, that's the inner knob, and that's the button. So I'm moving maybe 2 centimeters, and it's really cold up here in this room, and I'm kind of shaky. So if I want to enter something, I have to turn on the cursor mode. Get it to a point where I can enter something. Okay. Navigate to that field. And it's literally like 1/10 of a degree is a click. So if I want to enter a letter, let's enter CYXU for London Airport. So I need to find C. Move the outer knob 1 click. Move the inner knob 25 clicks to get to Y. So it's really like I'm already done with that. I'm not having fun with that anymore. Now, however, I designed and printed this new controller. So move my outer knob 2 clicks. Move the inner knob. CYX. U, London, Ontario. I don't have a button yet mapped to the enter key. And then activate that course. It's so much easier. I'm very excited at how well that works. And because I had extra encoders, I was able to map one of my encoders on the left here. Another frustrating thing is when you have to enter your altimeter barometer readings. So as you fly around to different areas, air pressure is different. You have to essentially calibrate your altimeter. It's another double knob, so you have to make sure you're in the right thing. And then you set it to the local air pressure, which this isn't as bad as the GPS knob, but it's still a pain in the ass. And if I've got an extra encoder, just go ahead and enter it. And because it's got a button function, I can press it, and it sets it to 2992, which is standard pressure. I'm going to be honest, like when I set this up, I literally just sat here for half an hour doing this and resetting it because I was so thrilled that it worked. This knob on the, I don't have anything mapped here to the middle knob right now, it's just extra. This knob is the range of the GPS. And then I put switches above and below it because I had switches laying around for the up and down functions. So up and down, left and right. So yeah, that's my new controller. I'm just really thrilled that it worked. Apparently I had the brakes off and I moved a bit. I wasn't paying attention. But yeah, this opens up a lot of possibilities. Knowing that this works, I might eventually, and very likely will eventually, build something that goes up and over, replacing this Saitek board panel. I need to have something with a pitch trim. But all these autopilot functions can totally be mapped somewhere else. This encoder here on this, where is it at here? Oh, it's here. This is how I normally set things, and this is controlled by this one. So I can set altitude, set vertical speed, set airspeed if I'm in an airplane that has automatic airspeed control, set my heading bug, and set my navigation direction. I could just have a separate encoder for each of these and not have to switch them. This is manufactured this way just for their own cost control, basically. But if I'm making it myself, I can make it however I want. It's pretty exciting for me. I'm sorry if you watched this whole video and found it boring. You should have known what you were getting into because most of my videos are like this. Yeah, that's essentially it. So yeah, that's basically it. That's my VR cockpit with my new thing I designed. I call it the encoder box. That's the name for it. I'm pretty happy with how it turned out. It was a good project to do if I'm stuck at home, laid off, like I am now. It lets me keep my soldering chops up. Keeps me thinking about certain gadgets and stuff. It was a lot of fun. I hope you liked this video. I don't know if it was a good idea or not to go live. Assuming you've been able to hear anything I've been saying. You're probably not hearing it now because the microphone's on this and it went away. If you didn't hear me a second ago, I was talking about how I like the design process. I'm very happy with how it turned out. I'm probably going to make more things similar to this. But yeah, it was a good way to kill some time while I was productive. Sorry if you watched this thinking there was going to be some kind of excitement for me actually flying in an airplane. I'll probably do another one of those. But I just wanted to show what I was working on for the last few days and how it turned out. Anyway, that's it. I'm sure I forgot something or a ton of things, but thanks for watching. Sorry again for the horrible video quality. This garbage webcam did its job better than this expensive webcam, so that's yeah, that's it.